So I'm back again, this time doing a video on application of derivatives, the questions that were asked in Telangana state exams on September 9, 2020. So the first problem on application of derivatives was the number of points on the parabola y square equals to x at which the slope of the normal drawn at the point is equals to the x coordinate of that point is out of these four, which is the correct one. So in this one, we know that the slope of tangent at any point can be calculated using dy by dx, right? So I differentiate this curve and I get the value of dy by dx. I put the values of x and y at that point at which we are calculating the slope of the tangent. That way I get the slope of the tangent. Now we know that the slope of the normal is -1 divided by slope of the tangent, right? So in that way I can find out the slope of the normal, and then I just equate it to the x coordinate of that point, and that will help me solve the value of the x coordinate of that point. If we get infinitely many solutions, this will be the correct answer 1, this will be the correct option similarly. So let's just start with the problem. Y square equals to x. I differentiate both sides with respect to x. What will I get? Bring the power down, decrease the power by 1. So 2 minus 1 is 1, so y raised to power y by 1. And so 2y and dy by dx, differential of x is 1. So 2y dy by dx equals to 1, or dy by dx is 1 upon 2y. So slope of tangent at any general point x comma y on the parabola is 1 upon 2y. So what will be the slope of the normal at that same point, which is equal to -1 by slope of tangent. So -1 divided by 1 by 2y is -2y, right? So slope of the tangent is -2y. Now this is slope of normal is -2y. This is given equal to the x coordinate of that point. So -2y is equals to x, right? But x comma y, the point that I have assumed here, lies on the curve y square equals to x. So y square is equals to x. So now two equations and two variables. So what will I do? I will just put x equals to -2y in this one. So y square equals to -2y. You bring this term over here, you will get y square plus 2y is equals to 0. Take y common, you will get y into y plus 2 is 0. So y is equals to either 0 or y plus 2 is equals to 0. That is y equals to -2. So 0 or -2 are the 2 points. And if y is 0, then what is x? X equals to y square. So 0 square is 0. And if y is -2, what is x? -2 square is 4. So there are 2 points, 0, 0 and 4 comma -2. So option C is the correct one. So this was fairly simple problem, should not take more than 1 minute. Okay, now this problem, the second one, I think it was a bit lengthy when I solved it. It's not a difficult problem, but it's lengthy. Okay, so let's just have a look at this question as well. Let alpha beta be the two roots of the quadratic equation x square plus ax minus b is equals to 0, where b is not equal to 0. If the straight line x cos theta plus y sin theta is equals to c touches the curve x by alpha raised to the power n plus y by beta raised to the power n is equals to 2 at the point alpha beta, then what is the value of a by b whole square plus 2 by b in terms of c? Okay, so first alpha beta are the two roots of the equation x square plus ax minus b equals to 0. So alpha plus beta is equals to minus a and alpha beta equals to minus b. We know this one, right? Secondly, the straight line x cos theta plus y sin theta is equals to c touches the curve at point alpha beta. That is, this line is the tangent to this curve at the point alpha beta, right? So now can we find out the equation or simply just the slope of the tangent to the curve at this point alpha beta? Yes, we can just calculate dy by dx and put x equals to alpha and y is equals to beta. You will find out the slope of the tangent to the curve x by alpha raised to the power n plus y by beta raised to the power n equal to 2, okay, at point alpha beta. Now this slope that we compute should be equal to slope of this straight line, because this straight line is the tangent. Equation of tangent is given to us. So I will find a relation between theta and alpha and beta from here. and I will have a relation between a, b and alpha beta from here, right? So let's just start solving this problem. So the straight line touches a curve at the point this, so we know that alpha beta satisfies this equation, and slope of the line is equal to slope of the tangent to the curve at this point. So x cos alpha cos theta plus beta sine theta is equals to c. This is because this point alpha beta also lies on this straight line. So substitute x with alpha and y with beta. Alpha cos theta plus beta sine theta is equals to c. Also the slope of the tangent to the curve x by alpha raised to the power n plus y by beta raised to the power n is equals to 2 can be computed by just taking the derivatives, right? So differentiate both sides with respect to x. This is a constant, so its derivative will become 0 first, and alpha and n are also constant, right? So they are set aside. Now the differential of x raised to the power n. Bring the power down, decrease the power by 1, right? Again, 1 by beta raised to the power n, because this is constant. Now differential of y raised to the power n. Bring the power down and decrease the power by 1. I have decreased the power by 1, so y raised to the power n minus 1, and differential of y will be dy by dx is equals to 0. Now I have to compute dy by dx at the point alpha comma beta, so I will just substitute x by alpha and y by beta in this equation. What will I get? Alpha raised to the power n minus 1 into n divided by alpha raised to the power n. Similarly over here, n by beta raised to the power n into beta raised to the power n minus 1 into dy by dx. Alpha raised to the power n minus 1 will get cancelled, and you will get only alpha here, and similarly only beta will remain here. So when you substitute it, you will get n by alpha plus n by beta into dy by dx is 0. N is also common, so you can cancel that out as well. So dy by dx is equals to minus beta by alpha. Now this is equals to the slope of the line, right? Because this is the tangent, so the slope of this tangent should be equal to this. And what is the slope of this line? Bring this term over here, you get y sine theta is equals to minus x cos theta. So y is equals to minus cos theta by sine theta into x plus constant whatever. So the slope is minus cos theta by sine theta. So minus cos theta by sine theta is equals to minus beta by alpha. Okay, minus beta by alpha is equals to minus cos theta by sine theta, or beta sine theta is equals to alpha cos theta. Also remember that alpha and beta lie on this line, so alpha cos theta plus beta sine theta is equals to c. And now we know that alpha cos theta is equals to beta sine theta. So both of these terms are equal to c by 2. I have done that over here. Alpha cos theta is equals to beta sine theta is equals to c by 2. So you can just say alpha is equals to c by 2 secant theta and beta is equals to c by 2 cosecant theta. Okay. Now alpha and beta are the two roots of this equation. So we know that sum of the roots is equals to minus a and product of the roots is equals to minus b. So a is equals to minus alpha plus beta and b is equals to minus alpha beta. We are asked to compute the value of this expression, which is a by b whole square plus 2 by b. A by b whole square plus 2 by b, so is equal to a square plus 2b by b square, because the LCM will be b square. Now a is minus of alpha plus beta. When you take the square, the minus sign disappears. Okay, so alpha plus beta whole square plus 2b, b is minus alpha, so minus 2 alpha beta divided by alpha beta whole square. Now alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta, so 2 alpha beta and minus 2 alpha beta will disappear, and you will only get alpha square plus beta square, and is divided by alpha beta whole square. Now what is alpha? As we have seen over here, c by 2 secant theta. So its square will be what? C square by 4 secant square theta. And beta is c by 2 cosecant theta, so its square will be c square by 4 cosecant square theta. And alpha is c by 2 secant theta, beta is c by 2 cosecant theta, so their product will be c square by 4 secant theta cosecant theta. Remember, this is also whole squared. So what will you get over here? C square by 4 into secant square theta plus cosecant square theta, and this is c square by 4 whole square. So c square by 4 will get cancelled, and you will get 1 by c square by 4 in the denominator, and when you take the reciprocal of it, you will get 4 by c square, right? And secant theta cosecant theta square will be secant square theta cosecant square theta. Over here, I was left with secant square theta plus cosecant square theta. I have replaced it with secant square theta, cosecant square theta, because secant square theta plus cosecant square theta is secant square theta, cosecant square theta. The proof is secant is reciprocal of 1 by cos square, right? Cosecant is reciprocal of sine, so 1 by sine square theta. When you take the LCM, you will get sine square theta plus cos square theta in the numerator. Sine square plus cos square is 1, we know that. So you will get here what? Sine square theta and cos square theta. Again, 1 by sine square is cosecant square theta, 1 by cos square is secant square theta. So hence proved. So this will get cancelled with this. You are only left with 4 by c square. 4 by c square is which option? Option B. Okay, so this was also an easy problem, but a bit time consuming, I would say. These questions are not tough at all. Okay, now let's look at question number 3. The number of admissible values of C obtained when the Lagrange's mean value theorem is applied for the function fx equals to x on 2, 5 is. This question should not take more than 5 to 10 seconds because it's just that easy, right? We know that since fx is equals to x is a linear function like this, so all the points satisfy the Lagrange's mean value theorem, so our answer is infinite. Let us see how it is to be done. Fx equals to x. Now as per Lagrange's mean value theorem, there exists a C such that f dash C is equals to fb minus fa by b minus a. F of x is x, so f of b is what? 5 and a is 2, so f of b is f of 5 minus f of 2 divided by 5 minus 2. Now f of x is x, so f of 5 is what? 5, f of 2 is 2 divided by 5 minus 2. 5 minus 2 is 3, 5 minus 2 is 3, so 1. F dash c is equal to 1. Now fx equal to x, if you take the differential, f dash x equals to 1. So f dash x is always equal to 1, always. For all the points between the points 2 and 5, the slope is 1. So all the points between the interval 2, 5 satisfy the Lagrange's mean value theorem. So this is infinitely many points like 2.1, 2.2, 2.3, 2.31, 2.32, 2.331. You get the point what I'm trying to say. So infinitely many points. So option C is correct. Now let us look at question number 4. Again a very simple problem. Very simple problem. The function fx equals to x cube minus 4x square plus 4x plus 3 defined on minus 1 comma 3 has minimum at this, minimum. Sometimes you don't even need to solve the problems. You can have a look at the options and try and substitute to see which option is the correct one. If I put f of minus 1 in this, what will I get? F of minus 1 is minus 1 minus 4 minus 5 again minus 4 minus 9 plus 3 is minus 6. So f of minus 1 is minus 6. Now let us look at x equals to 2. F of 2. 2 cube is 8. 2 square is 4. 4 times 4 is 16. So 8 minus 16 is minus 8. 4 times 2 is 8. Minus 8 plus 8, 0. So 3 is left. F of 2 is equal to 3. Right? And now f of 3. 3 into 3 into 3 is 27. 3 square is 9. 9 times 4 is 36. So 27 minus 36 is minus 9. Minus 9 plus 3. Minus 9 plus 3 is minus 6. Plus 12. Minus 6 plus 12 is 6. So f of 3 is equals to 6. Now let us look at the values of the options. Maximum value 9 at x equal to 3. We know that f of 3 is 6, so this option is not correct. Minimum value 3 at x equal to 2. At x equal to 2, the value is 3, correct, but minimum value is happening at f of minus 1, which is minus 6, so this is also not correct. Minimum value 6 at x equal to 3. Yes, f of 3 is 6, but the minimum value is happening at minus 1, which is minus 6, so this is also not correct. Minimum value minus 6 at x equal to minus 1. Done. I don't even need to solve the problem. I can just look at the options and tick one. But let us see how to solve the problem. Okay, if I don't do all of this. First, we have to examine if there are any maxima or minima in the defined interval minus 1 comma 3 for the given function fx. Fx is given is x cube minus 4x square plus 4x plus 3. Just take the derivative. Bring the power down, decrease the power by 1, 3x square. Bring the power down, decrease the power by 1, minus 8x plus 4 is equal to 0. Constant's differential is 0. Now you have to factorize it. So I have done that. 3x square minus 6x minus 2x plus 4 is equal to 0. So 3x minus 2 into x minus 2 is equal to 0. So x equal to 2 by 3 and x equal to 2. Right? Now we have to find out whether there is a maxima or minima at these 2 points. We know that the equation of the tangent will have 0 slopes at these 2 points. So these are either minima or maxima. Now let us find out which one is which. For that I will use the double derivative test. F double dash x is equals to what? Derivative of this 3x square minus 8x plus 4. So 6x minus 8, right? 6x minus 8. So f double dash 2 by 3 is what? Is equals to minus 4. Since this is negative, this is a local maxima. F double dash 2 is equals to 6 times 2 minus 8 is 12 minus 8 is 4. It is positive. So x equals to 2 is a local minima. So we know that the minimum value will happen at x equal to 2. So it won't happen at 3, right? At least that is the truth here. But f of 2 is what? When we substitute f of 2 in the given function, as I have already seen, f of 2 is 3. But we are asked on this interval minus 1 comma 3. Since this is an increasing function, right? As you go from left to right, the value will generally increase. And since there are f dash x equal to 0 has 2 roots, so this is how this curve should look like. So this is 2 by 3 and this is 2. This is x equals to 2. This is x equal to 2 by 3. Right? And this is x equal to minus 1. So in this case, as you can see, x equal to minus 1 has a value of minus 6. Even though the minima happens at x equal to 2, in the given interval of minus 1 comma 3, the minimum value is happening at x equal to minus 1. From this curve, if you draw the curve, you can realize what I am trying to say here. So on the defined interval of minus 1 comma 3, the function is minimum at minimum value of minus 6 at x equals to minus 1. As I have written over here. If you are confused, you can draw a graph, and I have drawn the graph in case you are confused as to why the minimum value is happening at x equal to minus 1 even though we have a minima at x equal to 2. Because it's an increasing function and the value at x equal to minus 1 is much lower than the value of function at x equals to 2. And so option A is correct, right? If you have any doubts, kindly reply in the comment box. Thank you everyone.